All right, and all right, I want 10 ohms. We'll call this guy R1, this guy R2. Okay. And I guess I'll call this point A. And we'll make this point B. And this is going to be R3, and this is going to be R4. And again, I'm starting off with, these are all going to be 10s. Okay. This guy will be R5. And he's going to be 10 also. And then we're going to have a R6, which will be 10. And we'll have an R7, which will be 10. And then I'll have an R8, which is 10. Okay. And then, see, this will be point B. Or no, that it can't be point B. I already got point B. This will be point C. Okay. And then we're going to come down here. And we'll have an R9. And then I'll go on back into my supply. Okay, so here we got 9 resistors and various combinations of series and parallel. Okay. By the way, thanks for replying, Nick, and letting me know somebody's still awake. All right, sometimes these Zoom meetings seem a little awkward because I feel like I'm just talking to my computer. Okay, so again, all the resistors starting off, this was an R9 here. Let me rewrite that. That's hard to read. So it's hard to draw this on a computer. Okay, I'd much rather be doing this on the board right now, but okay, so we're starting off, all resistors are 10 ohms. But what we need to do here is we need to start looking at this and seeing what we got. Okay, so looking at this, one of the things you might want to do is kind of redraw. So like if you look at this up here, okay, I could kind of redraw this. And it might be a little easier to kind of follow if I redraw it and kind of draw these two here. And these ones here. Okay. And, you know, you could have this like point B. You know, B1 or B2 or something if you wanted. All right. So one of the first things you might want to do, okay, you know, if we went back and we looked at my instructions, I said that we want to combine the resistors. And then we want to redraw the circuit. Okay. But, you know, honestly, sometimes you may want to redraw the circuit first. You might want to have step 0 to be a redraw and simply redraw the circuit to make it more obvious what's in parallel and what's in series, especially, you know, if you look at the back of every chapter, you know, at the end of every chapter in your book, they have all these circuits in here and, you know, all these sample problems for you to work with, and they like to try to make them look as confusing as possible. Okay. And so, so you want to, just whatever it you need to do there to take care of that. Okay. All right. So given that, we're going to look at our circuit and we're going to identify what we have. So before I actually even try to, I'm just going to maybe write down here. So we have R1 and R2 are in parallel. Okay. And then we can also say, well, wait a minute, R3 and R4 are in series. And then we can say, well, wait a minute, 6, 7, and 8 are in series. Okay. So we've got R6, 7, R6, comma, R7, comma, R8 are in series. And so now I can come in and start combining these. So I'm just going to kind of grab, maybe what I'll do is draw a box around here. So I'm going to take these two, right? And those are going to be in parallel. And I'm going to redraw that then. Okay. So we need to calculate what that is. So R1 all right, so R1, 2 is R1 in parallel with R2. So that's 1 over 10 plus 1 over 10, right? And that turns out to be 5 ohms, right? And I'm writing my 3 digits. I could put this in Blackboard. Okay. So now I want to redraw my circuit. So I'm going to go back to my black color and I'm going to redraw the circuit. Put a little separator here. Okay. And then I'm going to redraw my circuit. So I have my 10 volt supply E. I should have labeled that E like the book does. A lot of times I don't do that. All right. But now here I've got, here's point A. Go ahead and label point A. And then I'm going to change my color and I'm going to have my new resistor, which is called R12, which is a 5 ohm resistor. Right. And then this was point B or B1 if you want. Because I labeled this B1 and B2 here. Right. So then you're going to also have point B2. Okay. But now I'm going to go back to my black. And then I'm going to have R3 up here and R4 and R5 and R6, R7 and R8. I don't know why I'm doing this. I could have just copied and pasted probably, and then R9, I'm going to shift it a little bit, or whatever, and draw it right there. Okay. And so this is, this is kind of my first reduction. All I did was reduce that one piece right there. Okay, and so this was, point B or B2 here, and this is point C over here. So go ahead and relabel those. Okay, so now we can try and combine. So I'll grab a different color and I'm going to grab these two, R3 and R4. Okay. And I don't know. Okay. So, all right. So now I'm going to, okay, so now I'm going to have R3, which is in parallel with R4. So that's going to become a resistor I'll call R3, R34. And that is, oh, that wasn't parallel. Sorry, that was series. Okay. So that was R3 in series. I'll use a big S here, series with R4, right? So that simply is 10 ohms plus 10 ohms, which gives me 20 ohms. Okay. And so now what I'm going to do is I'm going to redraw this circuit. And yeah, it just occurred to me that, gosh, I could copy and paste this and save some time, right? So I'm going to redraw this and then cut out this bit, okay? And so you may want to come in there and label it or something if you feel you need to, but now I'm going to draw in this new resistor, R34, which is 20 ohms. So now we can grab some other color, and I'm going to combine these three. All right, so just to keep track here, I'll kind of, okay, this was like circuit. This was my second drawing because I had my original drawing. This is my third drawing, so this is going to be the fourth drawing, so I can keep track of where I'm at. Okay, so I've got R6, 7, and 8 now. So now I have, okay, I have R6, which is in series with R7, which is in series with R8, right? So that's going to give me a resistor we'll call 6, 7, 8. And that is simply 10 ohms plus 10 ohms plus 10 ohms, which is now 30 ohms, right? And so now I can redraw this circuit. Which I can kind of take a shortcut and copy and paste it. And just cut this out here now. And so this here now is my new resistor, which is R6, 7, and 8, which is 30 ohms. All right, so now we look at this again. And now we can see that these are all in parallel. Okay, so here's my fifth circuit. Okay, And this is going to combine. So I have R34, which is in parallel with R5, which is in parallel with R6, 7, and 8. Okay, so I'm going to call this is going to be my resistor R3, 4, 5, 6, 7, 8. Okay, seems like a lot, but it helps me keep track of what I've combined there. Okay, now if you get into a circuit that's got like 10, 11, 12, or 20 resistors, you might need a new naming structure to keep track of them. But this is what I kind of like to use, especially if if I'm less than 10 resistors, which is why I stopped at 9. Okay. All right. So this combination now, remember that R34 was 20 ohms, right? So that's 1 over 20. 1 over 20. R5. Now R5, we hadn't done anything with R5 yet. So that was the original 10 ohms. Okay, so plus 1 over 10. And then 6, 7, and 8 was 30. All right. Now, before I even punch this into a calculator, okay, and go ahead and use the chat here. I'm going to let you guys think about this for a second or two. What do you think the value of your resistance is going to be here? Okay. Do you think it's going to be maybe 6 ohms? Do you think it's going to be 60 ohms? Do you think it's going to be 100 ohms? Anybody got a guess at what this is going to be? Yeah, exactly, Matthew. It's going to be less than 10. Thank you. Right. So we know that current likes to take the easy way. And so most of the current is going to go through R5, the 10 ohm resistor. And but some of the resistance or some of the current will end up going through the other 2 resistors because they'll be like, hey, too much traffic on R5. I'm going to take one of the others. But we know before we even try to punch this in the calculator, we should end up with a number less than 10. Okay, so now if I'm going to come over here into, at this point, I didn't need a calculator, but now I need a calculator. Looks like it timed out on me here. And I thought I installed Octave on this thing, but okay. So anyhow, I'm going to come over here. I'm going to clear. Okay, there's a command in Octave you can run called whos, and it'll show you all your variables, which and then clear will clear all your variables. CLC will clear the command line, which is just to clear your entire screen. So CLC is like clear the commands or clear the screen. Okay, clears your variables, and whos shows you your variables. Okay, you can actually do who or whos with an S. Either way, they give you slightly different information, but anyhow, so let's see. I have my resistor R 3, 4, 5, 6, 7, 8. Okay, this resistor is going to equal, and this is the equation that I have right over here, right? So it's going to be equal to 1 over, and again, do not forget your parentheses. All right, so it's going to be 1 over 20 plus 1 over 10 plus 1 over 30. Okay, and and as Matt pointed out for us, right, the value that we get better be less than 10. If it's not less than 10, we're going to have an issue. Okay. All right, so so here's my answer out to 5 digits. Okay, so and like I told you before, even though I started out with all nice round 10 ohm resistors, now I'm getting weird values, right? So now the result of this resistor is 5.4545. 4545, let's say. Okay. And you know, so that is, you know, so that is that resistor. So now one more time I can redraw this. Okay. So I'm going to take this, I'm going to copy this down here. Okay. But then I'm going to chop off all of this. Okay. Which I'm going to replace with this resistor. Okay. Boy, I'm loving copy and paste here. I don't have to write all this stuff. Okay. And so now I've got this resistor here, which is R3, 4, 5, 6, and 7. Okay, which is this 5.4545 ohms. Okay. Now, we're almost done here with the reduction. Okay, so we're almost done with the reduction. And so we've got this. Did I use brown? I'm trying to find a color here to use. I try to stay away from yellows and things because. All right, so now if we look at this circuit here, right, you have R1, 2, R3, 4, 5, 6, 7, 8, and R9. These guys are all in series. Okay. Okay, so we have R. Oh, okay, so this is my 6th circuit redraw here. And so I have R1, 2, which is in series with R3, 4, 5, 6, 7, and 8, which is in series with R9. And so that's going to give me this resistor R1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And so maybe I'll just shorten that as R19. How's that? Okay. So that's going to be equal to R12, which was 5 ohms. That was the first combination we did. So we have 5 ohms. And then we have this 3, 4, 5, 6, 7, 8 one. That's the one we just did. So that's 5.4545. And then we have R9. Now R9 we haven't done anything yet with, so that guy was still 10 ohms. Okay, so there's another 10 ohms there. So this is going to give me a resistance of let's see, 10.4545 ohms. Now, if I got to put this into Blackboard, right, because this actually, right, now my new circuit here, this is my R19, right, and then go back to black for a minute, right? So here's my voltage supply, my nice round 10 volts, feeding this resistor. So I've reduced this whole thing. I've reduced all of this, and I've walked through and I've got it reduced down to a single resistor. Okay. And so if I'm going to put that answer in Blackboard, the answer becomes 10.5 ohms. Okay, so the total resistance. Okay, so what we're saying here, this is the R19 is the total resistance of this circuit as seen by the power source. Or the voltage source, if you want, you know, technically it's a voltage source, but it supplies, it'll supply power because, you know, once we hook it up, we hook up to 10 volts, we will get current flow. So it's also supplying power. Okay. All right, so now we can then, therefore, now we can come in here and we can say, well, what is the total current this guy is dishing out, right? So what is the current this guy is dishing out? Well, this guy here is dishing out the current. Oh, yes. 20. Oh, thank you. I can't do math. Sorry. 20. Good catch. Okay. Sorry. Yeah. 5 and 5. It was 10 and then 10 there. I apologize for that. Good. Thank you for thank you for raising a hand. So catch that. I see Tim put the answer in there, but I've got the chat on my other screen, so I didn't look over it. Okay. All right. So I assume that's why you raised your hand, Isaiah. Is that correct? Okay. So yeah, thank you for that. Okay. So the anyhow, so the total current is going to be E divided by this total resistance, which is, you know, this R19 labeled resistor that I have. So it's 10 volts, but now we're going to divide it by 20 point. And again, you don't want to use this 0.5. You want to use more significant digits, okay? Because otherwise you will get round off error, okay? So you need to take it out to at least 5 digits. In this case, I'm just going to go ahead and go out to 6 digits. Okay, you can never be wrong by adding digits. You're only going to get in trouble if you start dropping a few. Okay, so now we can calculate I total. So pop back over to my thing. I can go I total here. Hello. Okay, so I total is going, well, let me go ahead and I'm going to go ahead and put in R19 is equal to 20.4545. Okay, and now I can use it later on. So I can then go I total is the 10 volts divided by the R19. Okay, and so we can calculate that. I can also calculate total power, right, which is going to be the 10 volts times I total. Okay, so we can take those values there and put them in there. And you know, sometimes I just like to paste the values in here instead of rewriting them. Okay, I'll just write them down here. Okay, so there's my values. Make them a little bit bigger to read. Okay, so there's my total current and my total power. So again, if I was going to put this into Blackboard, right, my total current inside of Blackboard, I would write this as 0.489 amperes. Or if you prefer, you can put 489 milliamperes. Power total here is going to be 4.89 watts, right? The units for power is in watts. Now, we can work our way back through these different circuits, okay? And so one of the things we can do is we can just come in here and calculate the colors, or not the colors, the voltages, okay? And so what I'm going to do is I'm just going to come in here and calculate the voltage. What is this voltage? What is this voltage? What is this voltage, right? Because these three are in series. So I know the current, right? There's my current. Okay, there's my total current. So I know my total current. And so I can therefore calculate what the voltage is across this resistance and across this resistance and across this resistance using Ohm's law. So if I flip back over to my calculator, and I can put in that the voltage V12, shrink is down some so I can see, okay? So this is resistor R12, so the voltage across that is going to be my I total times R12, which is 5 ohms. So it's going to be 2.24 volts. .444 volts. So I'm going to come over here and write that down. So this voltage is 2.444 volts. And then I can do the R3, 4, 5, 6, and 7. Okay, and that was the 20. No, that was my total resistance. Okay, so R3, 4, 5, 6, and 7, this resistor right here, right, is 5.4545 ohms. So that voltage, so that's the voltage V. Hello. V 3, 4, 5, 6, 7, 8 voltage. That voltage is 5.4545 times I total, which is 2.6666. Okay. So this voltage here is 2.6666. Okay. And then the voltage R9 so the voltage V9 is voltage across R9 is going to be 10 ohms times I total, which is going to be 4.8889. .888. I don't know how far those eights go, but all right. So now we can double check this. Okay. So again, we can double check this here using Kirchhoff's voltage law, right? So we can say, well, wait a minute, Kirchhoff's voltage law, KVL, says that the 10 volts must equal the sum of these voltages. So we take 2.4444 plus 2.6666 plus 4.8889. That better equal 10 volts. Okay, and so I can actually do this in my calculator now. I can take V12 plus V3. Now you can, I named this thing V3, 4, 5, 6, 7, 8, but if you hit the tab key, it'll pop it up there and you can just click on it. And then plus V9, and that should equal 10 volts, right? Okay, so this was a double check that I calculated those right. And so now these voltages, I can actually come in here anywhere in any of my circuits, right? So I can come up here and say that this voltage here is 2.4444. And this voltage here on this box, right, is 2.666. And this voltage over here, of course, is 4.889. And, we can do that at any point in this circuit. Okay. So, over here, this right here has a voltage of 2.66 volts. So if I wanted to calculate, like if the question in the homework was simply asking, what is the current through R5? Let's say that was the question. Let's say I didn't care about all the rest of the currents or voltages. I'm saying that the whole question was, how much current's running through R5? Well, at this point, right, I know that this voltage is 2.66666 volts. So I can simply calculate the current I5 at this point is going to be that voltage of 2.6666 volts divided by the resistance of R5, which was a 10 ohm resistor, right? And so that's going to give me a current of 0.2666 amperes. And so to put that in Blackboard, right, we could put in some, 0.267 amperes, or we could put it in as 267 milliamperes. All right, so you don't necessarily have to go back through the entire circuit. If the question isn't asking for every single current through every single resistor, you can just kind of work your way back and answer what the question's asking. So if we were asking for the current through R8, let's say we're asking for the current through R8. Well, again, we know that the voltage, we don't know the voltage R8. We know the voltage from here to here, right? So what we'd have to do is calculate the current through R8. So let's say that I'm looking for the voltage V8 and the current I8 and the power of this resistor 8 here. And so what the easiest thing to do would be at this point would be to calculate the current. Okay, so but what I would have to do is find the current through this combined resistor here, which is 30 ohms. Okay, and so I8 is going to be the voltage V3, 4, 5, 6, 7, 8. right? That's that voltage of 2.66 divided by the combined resistance of R6, 7, and 8. Just these three resistors. Okay. And so that would be the 2.666 volts divided by R678, which was 30 ohms. Okay, and so that current, I have to calculate that one. I don't know that one offhand. All right, so I8, which is I8 is going to be equal to V34. Again, hit the tab key and you can fill that out. Divided by the 30 ohms of those three resistors in series, which gives me 88.8 milliamps. Okay, so the answer there is 0.0888, and these eights probably go on forever. And so to put this in Blackboard, I would put in 88.9 milliamperes. Okay, that's how I would have to put the current I8 in. And then given that, we can calculate the voltage drop across V8, right, which is I8 times R8, and R8 was an ordinary 10 ohm resistor, right? So that's going to give me 889 millivolts. Okay, 889 millivolts. And then we could calculate the power P8 now, because we know the voltage and we know the current. We could also define the power. Okay, so the power, I've got the power P8 is, I can either say V8 times I8, or I can just say I8 squared. Okay, so to do a square, you can do that, or you can just multiply it times I8 again. Okay, either way. Times the 10 ohms of R8. And so the power is going to be (0.079011) watts, right? Units of power in watts. And so to put that into Blackboard, we would put 79.0 watts, right? We cut it off at the 3 digits, you know, and make it milliwatts. It's milliwatts, right? So you're going to move over 3 decimal places. Okay. So that is the power. So we've calculated, you know, we were able to then define, you know, the power and the current and the voltage for resistor R8. And we can do that for any of our resistors. All right, so any questions, comments? All right, so we only have a few minutes left. What I want to do is introduce you to this Multisim software. Okay, so Multisim is a simulation software where we can build up electrical circuits. And I have the instructions in Blackboard under the start here, where you can register that this is software is from National Instruments. Okay, so NI, National Instruments. And so you actually have to go to their website, ni.com/multisim. And then you can register as a student of Stark State, and you can download a copy of this for your home computer. Okay, because it's, you know, we have a license agreement with them that students can utilize this software, but you have to register it. So the instructions for that are in Blackboard. Okay. Well, what I want to do is just simply kind of show you how to connect up this, to connect up a circuit and run it. And since I just spent, an hour going over this circuit, I'm going to go ahead and use this circuit that I have drawn here. Okay, and so what we want to do is when you open it up, you get this like drawing sheet here. And if you look up here on the toolbar, you'll see there's something called place source. And so you click on that and it pops up a window. And you can select whether you want a DC current source or an AC power source or whatever. So what I want is DC power. And that gives me a little battery symbol. And I can drag this around and then click it where I want it. Now, then it's going to pop this back up. Now, one thing you have to do to simulate it is you have to have a ground symbol. So I'm going to come down here also and grab my ground symbol, and I'm going to place that on here. Okay, now it pops this up. I'm done with sources, but I need to go to basic elements now. And what I want to do is grab a resistor. So if we look through here, we'll find a resistor somewhere. Okay, and it defaults to 1K resistor. And you can change this right now, but I'm not going to. I'm just going to say okay, and I'm going to drop this resistor in here. Okay, so there's my resistor R1. I'm going to go ahead and close this now. I'm going to double click on the resistor, and it's going to pop this up, and you can change the value of resistance or whatever later on by double clicking on it like this. Okay, and then you can also like change the label if you don't like the label name. Okay, so but there's my resistor. I set it to 10 ohms. Now I'm going to do a Control C to copy it and a Control V to paste it. And I'm just going to build up my circuit. This was R9, okay, and I'm going to rotate this. So they're all running horizontally, but this one I'm going to run, I'm going to rotate this 90 degrees and make that vertical, okay. Now here are these, we can kind of drag them around. Now what we need to do is connect them, okay. So what I'm going to do is I'm going to take click on the terminal of R1 and drag it down here to V1. And then I'm going to click on the negative of V1 and I'm going to run it over here to R9. Okay. And I kind of, and then you can click on it and sort of drag it around a little bit if you need to. Now, when you try to connect a third one, what you want to do, you keep like if I need to draw a line to my ground, but I can't like click on this and drag the line to the ground. I need to click on the ground and drag it up, and then it gives me this little dot here. Okay, so it gives me a little dot to show that it's connected. All right, so same thing with like R2 here. I'm going to take R2 and run this up and connect it there. And take it over here and connect it there. Then I'm going to take like R3 and connect here. And all I'm doing is starting at one of the terminal tips and running it and joining these. Okay. And then you can shift them up a little bit to line them up, make them look a little bit nicer. And you just need to connect all these lines. I'm just clicking on it, and then I click right there. Once I click there, I can drag the mouse around and it follows the mouse, and then I click on another terminal and it'll make the connection. If you need to delete a connection, you click on it, it highlights it, delete it. Okay. So, so here's the circuit that we just spent quite a lot of time analyzing. And what I want to do now is measure these values. Now you can actually come over here, you can go to tools, or sorry, not tools, simulate, and you can go to instruments and you can grab a multimeter if you want. So I can grab a multimeter and take this meter and I can connect it to, say, R8. Okay. And now it'll measure and tell me what the voltage is. Now it's not showing anything because I have to simulate it first. Okay. But before I do that, I also want to show you these voltage probes. Okay. And these current probes. So if I click on the voltage probe, I can put a voltage probe here. And it gives me all kinds of different voltages. It gives me AC voltage, DC voltage, and all that. Right now, we're only talking about DC. So the only thing I want to see is DC. So if I double click this and come over here to parameters, I'm going to go to custom parameters. And I'm going to turn off everything but DC voltage. So all these yeses, I'm going to click the no's except for the DC one. I'm going to leave that as a yes. Okay, so that gives me this voltage. All right, and now as I take this, I can right click on it, or left click on it, highlight it, do a Control C, and then do a Control V, and you can get another copy of the probe that is already limited to just DC voltage. Okay, and then you can, so you can put these probes everywhere. However, please note that these probes are measuring to ground. So if you want to measure like just the resistance off of R8 here, okay, that PR1 is the name of the probe there. So I kind of drew this resistor down a little bit lower to make it stand out. Okay. All right, so, but anyhow, if you need to measure just across a single resistor, you need to like grab the multimeter here. The probes always measure all the way to ground. So they're measuring from where you're at in the circuit to ground at all times. And we can also do current probes. Okay, so it's kind of the same thing with a current probe. You can just take and grab a current probe and stick it in here. Again, it shows you RMS voltages and peak to peak voltages. That's AC stuff we'll talk about in the AC class. So I'm going to come over here and customize it. So I want to see nothing but DC. Okay, so I'm going to hit apply there and say okay. And so that's going to show me that. And then I can, I can click on this and I can put the current in different places, this current probe in different places here to measure different currents. So I get these PR just stands for probe. So I got, probe 5, which is a current probe. I got probe 3 up here, which is a voltage probe. Okay. So, and you can throw in as many as these as you want. And then when you're ready, you come up here to the little play button and hit play, and it will simulate and show you the voltages and the currents throughout the circuit. Okay, so remember that the voltage across the resistor R9, if I go back to my drawing here, right, we had a voltage R9, which was 4.88 volts. Okay, and this is saying 5.87 volts. Okay, I forgot to mention when I threw the voltage on here, I got 12 volts instead of 10 volts. Okay, so I need to stop the simulation. I'm going to come up here and stop the simulation. I got to double click on this. Okay, and this should be like an E instead of V1. They label them V's, the book label them E, whatever. Okay, but I need to come to the value and I need it to be 10 volts, not 12 volts. That's why my currents and voltages were off. So then I'm going to hit play again, and I should have 4.88 here. Here is my voltage across V8. Come on. Okay, so right? If we look at this, right, the voltage V8 is 0.889 volts or 889 millivolts, right? So that's what it's showing me here, 8888889 millivolts. Okay. The current, this probe right here is showing me the current through R6, R7, and R8. They're all in series. So it's showing me that it's 88.9 milliamps, right? This current right here. Okay. My total current is 489 milliamps. Is that what I calculated? I forget. Let me come back and look. 489 milliamps. That was my total current. Okay. So this is the simulation software that they were talking about at the in the exercises of lab 9. It's called Multisim, and it makes it very easy to build up a circuit and be able to measure and read voltages and currents and all that fun stuff. Okay. All right, any questions there? I know I went through that pretty fast. I did hit record here for this last circuit and this multisim stuff here. So, you know, if you're interested, remind me and I can post this video out there so you can watch it again and just go through it. All right, but the Multisim software is pretty cool. You can work through it to you know, or you can build up the circuit and put these probes or these multimeters in here to measure currents and voltages and things like that. And it, you know, works really slick, and you know, you can see your values, but you need to be able to calculate them also. All right, any questions, comments? Okay, so I'm still waiting to hear back from HR and stuff. I'm not 100% sure. Remember, Monday's a holiday, right? So you know, there's no class Monday either way. When we come back to class, we will do the parallel lab, parallel resistance lab, and then let me look at Blackboard here real quick.